Hello everyone, this is Kalpana here. In this video, we're going to solve an assignment problem using Hungarian method. So let's get going. Problem. A project work consists of 4 major jobs for which 4 major contracts have submitted tenders. The tender documents quoted in thousands of rupees are given with the matrix as. So we are given a cost matrix. Jobs, 4 jobs, 4 contractors. Find the assignment which minimizes the total of the project cost. Each contractor has to be assigned one job. Okay, so we are asked to find the assignment which minimizes the total of the project cost. That means which minimizes the total cost. Okay, so we are given a cost matrix which is given in thousands of rupees. Okay, 15 is nothing but 15,000, 27,000, 35,000, 20,000, 21,000, 29,000, 33,000, 17,000, 17,000, 25,000, 37,000, 15,000, 14,000, 31,000, 39,000, 21,000. Okay, a project work consists of 4 major jobs. Okay, a project work consists of 4 major jobs for which 4 major contractors have submitted tenders. Okay, let's solve the problem. And it is a cost matrix which is given in thousands. I mean, tender documents quoted in thousands of rupees are given with the matrix. So we are given a cost matrix. It is in thousands of rupees. Okay, now coming to the problem, and we have to observe that each contractor has to be assigned one job. Okay, given cost matrix, $15, $27, $35, $20, $21, $29, $33, $17, $17, $25, $37, $15, $14, $31, $39, $21. Jobs J1, J2, J3, J4 and contractors C1, C2, C3, C4. So here number of rows equal to number of columns. We are given a 4 by 4 matrix, right? Since number of rows equal to number of columns, we can say that the problem is a balanced one. It is a balanced problem. Okay, step 1. Choose the least element in each row and subtract it from all the elements of the row. So let's choose the least element from each row. So in the first row, 15 is the least element. In the second row, 17 is the least element. In the third row, 15 is the least element, and in the last row, 14 is the least element. So we have to subtract all the elements with this least element. All the elements with 17, all the elements of third row with 15, all the elements of last row with 14. Okay, so I'll consider the first row 15, 27, 35, 20. Right, we need to subtract all these elements. What I mean is we need to subtract this least element 15 from all these elements. Okay, 15 minus 15 0, 27 minus 15 is 12, 35 15, 20, 20 minus 15 5. So we'll get 0, 12, 25 in the first row. Now coming to the second row, you're having 21, 29, 33, 17, right? So here least element is 17, so we have to subtract 17 from all these 4 elements or entries. (21 minus 17 4), 29 minus 17 is 12, 33 minus 17 is 16, 17 minus 17 0, so you'll get 4, 12, 16, 0 in the second row. Now coming to third row, 17, 25, 37, 15. So we need to subtract 15 from all these entries. (17 minus 15 2, 20 minus 15 10, 37 minus 15 is 22, 15 minus 15 0. So you'll get 2, 10, 22, 0 in the third row. Now coming to the last row, 14, 31, 39, 21. We have to subtract 14 from all these entries. (14 minus 14 0, 31 minus 14 17, 39 minus 14 25, 21 minus 14 is 7, right? So here you'll get 0, 17, 25, 7 in the last row. This is the reduced matrix. Now coming to step 2. In step 2, we'll choose the least element in each column and subtract it from all the elements of the column. So firstly, we'll choose the least element from each column. In the first column, 0 is the least element and we have 2 zeros, right? And here 10 is the least element. In third column, 16 is the least element, and in last column, 0 is the least element. If 0 is the least element, you'll get the same entries in that column when you when you subtract the least number from all the entries of that column. Okay, so let's see. In the first column, we have 0, 4, 2, 0, right? 0 minus 0, obviously 0, 4 minus 0, 0, 2 minus 0, 0, 0 minus 0, 0, right? You'll get the same entries in the first column. Coming to second column, we have 12, 12, 10, 17. You have to subtract the least element from all these entries, right? So subtract all the elements with 10, you'll get 2, 2, 0, 7, right? In the second column, you'll get 2, 2, 0, 7. Now consider the third column. We have 20, 16, 22, 25. So here 16 is the least element, so we need to subtract 16 from all these entries. Four, 0, 8, so 22 minus 16 is 6, 25 minus 16 is 9. So you'll get 4, 0, 6, 9 in the third column. and in the last column you're having 0 as your least element, so you'll get the same entries in the last column 5007. This is the reduced matrix. Let's now try to make an assignment. We have to choose only one 0 from each row and each column. Okay, let's see. I like the same matrix, that is a reduced matrix again. 0, 2, 4, 5, 4, 2, 0, 0, 2, 0, 6, 0, 0, 7, 9, 7. Right? So I'll begin with the first row. In the first row we have 1 0, right? But in the same column, in the first column we have another 0. Okay? So if you want to make an assignment, just mark the 0 and cross the remaining 0 in that same column or same row. Okay, since we have marked the 0, so there is one more 0 which exists in this column, so we'll cross that 0. Okay, now if you notice you're having 2 zeros in the second row and 2 zeros in the third row, right? Now let's check the columns. In first column already we have assigned 1, and in the second column we have one single 0, right? Let's assign this and let's cross the 0 which occurred in the corresponding row, right? Since we have crossed this 0, so we can assign this 0 and cross the other 0 which occurred in the corresponding row. Right? So we have only 3 assignments. So here the optimal solution is not obtained. Right? Or you can assign this 0 also. If you wish, you can assign this 0. Let's see what happens if we assign the last 0. If we assign the last 0, we'll cross the corresponding 0. We'll cross the 0 which occurs in the corresponding column. Now, you can just simply assign by looking at rows. We need to check the columns. So here we have single 0. Cross the 0 which occurred in the corresponding row. Now, since we have crossed this, so we'll assign this 0 and cross this 0. Right? Here also you'll get 3 assignments. Okay, we'll choose this one. Hence, no optimal solution is obtained. Now coming to step 4. Now we'll take the reduced matrix of step 3. Okay, 0, 2, 4, 5, 4, 2, 0, 0, 2, 0, 6, 0, 0, 7, 9, 7. Right? So here, now observe the row which has no assignment. See here, the last row, since the last row has no assignment, so we'll mark the last row. Okay, and in the same row we have a 0 which exists in the first column, right? So we'll mark the first column. Again, in the marked column we have one assignment, so mark the first row. Okay, since last row has no assignment, so we mark the last row, and there is a 0 in the first column of the marked row, so we'll mark the first column, and we have an assignment in the first row of marked column, so we'll mark the first row. Okay, now draw straight lines through all the unmarked rows and marked column. We have to draw straight lines through all the unmarked rows and marked column. Okay, and here we have 1, 2, 3, 3 lines. Okay, and number of assignments 1, 2, 3, right? And here we have 1, 2, 3, 3 lines, which is less than the order of matrix, which says that it has no optimal solution. Since these 3 lines, we have 3 lines which is less than the order of the matrix. Order of the matrix is 4, right? 4 by 4 or 4, which shows that the assignment is not optimum. So what we'll do is we'll pick the least element of this, which is uncovered. We'll pick the smallest element which is not covered by these lines. So the smallest element which are not covered by these 3 lines is 2, right? So 2 is the smallest element. So what we'll do is we'll subtract 2 to the elements which are not covered. Okay, we'll subtract 2 from all the elements which are uncovered, and we'll add this 2 to the intersection of, to the number which exists in the intersection of 2 lines. Okay, let's see. Zero will be as it is 0, 2. We have to subtract 2 from all the elements which are uncovered by these lines. Okay, so 2 minus 2 is 0, 4 minus 2, 2, 5 minus 2, 3. It is in intersection, right? So we have to add this 2 to this 4. So 2 plus 4 is 6. You can write these numbers as it is. Again we'll have an intersection. So add 2 to this number. So 2 plus 2 is 4. And again you'll write these 3 numbers as it is, or 3 entries as it is. This number or this entry also as it is. And here you're having 7, which is uncovered by lines. Okay, so we'll subtract 2 from this 7, 9 and 7. 7 minus 2, 5. 9 minus 2, 7. 7 minus 2, 5. See, choose the smallest element not covered by the lines is 2. So subtract 2 from all the uncovered elements. Subtract 2 from all the uncovered elements. 2, 4, 5, 7, 9, 7 are the uncovered elements, right, which are not covered by the lines. And add 2 to the elements lying at the intersection of the lines. We have added 2 to the elements which are lying at the intersection of 2 lines. We have added 2 to this 4 and 2. See, we got 4 plus 2, 6, 2 plus 2, 4, right? Fine. Now let's try to make an assignment. Now coming to step 6, we'll try to make an assignment. Each row and each column should have 1 0 or 1 assignment. Check which row has only 1 0. In first row we have 2 zeros, in second row we have 2 zeros, in third row we have 2 zeros, and in the last row we have 1 0, right? So let's assign this 0 and cross the remaining 0 which exists in the corresponding column or row, right? Now we have crossed this, so we need to assign this 0 because there are no other zeros here. Since we have assigned this, so we'll cross the corresponding 0 which existed in the corresponding column, right? Since we have crossed this 0, so we'll assign the corresponding 0 which existed in the corresponding column, right? Since we have assigned this, so we'll cross the 0 which exists in the corresponding column. Since we have crossed this, so we'll assign this 0 which exists in the corresponding row. Right? So we have only one assignment from each row and each column. We have one assignment in the first row and second column. We have one assignment in the third column and second row. We have one assignment in the fourth column, third row, and we have one and only one assignment in the first column, last row. So we got the optimal solution here. Since each row and each column has one and only one assignment, and the optimum solution is reached, right? The optimum assignment is contractor C1 has to be assigned to J2, right? C1 is assigned to J2, C2 is assigned to J3, C3 is assigned to J4, C4 is assigned to J1. C3 to J4 and C4 to J1. Contractors C1, C2, C3, C4. Jobs J2, J3, J4, J1. Cost. Now compare this matrix with the given matrix. You have cost, you have assigned 0 here, right? So you'll get cost 27 for C1 J2 and C2 J3 33 cost. C3 J4 has 15, C4 J1 has 14. So we'll add all these costs to get the total minimum cost. Total minimum cost equal to 27 plus 33 plus 15 plus 14. 27, 33 is 60, 15 plus 14, 29, which is 89. If it is in thousands of rupees, you'll get 89,000 rupees. The total minimum cost will be 89,000 rupees if we are given the cost matrix in thousands of rupees. Okay, so this completes the problem. So we have discussed a problem from assignment model in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.